So, let's go. 10 theories that suggest our galaxy is full of dead civilizations. The math says the universe should be crawling with them. The silence suggests something went very, very wrong. And the scariest part isn't that they're gone, it's what their disappearance might mean for us. Number 1, the math that broke physics. Here's the thing that keeps astronomers up at night. The Milky Way is 13.6 billion years old. It contains somewhere between 200 and 400 billion stars. We now know most of those stars have planets. The numbers are so large they stop feeling real. But here's where it gets uncomfortable. A civilization with basic rocket technology, nothing exotic, nothing faster than light, could colonize this entire galaxy in about 1 million years. 1 million. Human civilization has existed for 12,000. We are not even a rounding error on that timeline, which means if even one civilization arose just 500 million years ago, a blink, cosmically speaking, its probes, its signals, its footprint should be absolutely everywhere by now. Every star system touched, every corner claimed. And yet, no signals, no megastructures, no visitors, nothing. The universe looks exactly like it would look if we were completely alone. Think about what our presence actually amounts to. Our radio signals have been leaking into space since around 1900. That gives us a bubble roughly 125 light years across, in a galaxy 100,000 light years wide. We have whispered into a football stadium from one end zone, and we're confused that no one heard us. If you compressed all of galactic history into a single calendar year, every human being who ever lived, every war, every civilization, every song, all of it fits inside the last 18 minutes of December 31st. This video isn't about whether aliens exist, it's about where they all went. Number 2, the Great Filter. Something kills everything. In 1996, an economist named Robin Hanson asked a question that sounds simple and isn't. If the galaxy should be full of civilizations, and it isn't, then something must be stopping them. Some step in the chain from dead matter to spacefaring species is so difficult, so improbable, that almost nothing makes it through. He called it the Great Filter. The chain looks something like this. You need the right star system, then chemistry complex enough to copy itself, then simple life, then complex cells, then multicellular life, then something intelligent enough to use tools, then a civilization, then actual expansion into space. 9 steps, roughly, each one a wall. Here's the part that should make your stomach drop. Either the filter is behind us, meaning all those steps were the hard part, we somehow cleared every single one, and the universe ahead is wide open, or the filter is still coming. And if it's still coming, it means every civilization before us, the ones that cleared every wall we've cleared, hit the same wall we're about to hit, and didn't make it. A paper from 2026 ran the numbers on this. If intelligent life is reasonably common, then based on the silence, civilizations must be surviving for at most 5,000 years after they emerge. 5,000. That's shorter than ancient Egypt lasted. And here's a detail that biologists have been trying to tell astronomers for decades. Substantial tool use, the kind that leads to technology, has evolved exactly once on Earth. Once in 4 billion years of life. That might not be a coincidence. It might be the filter. Finding life on Mars would be wonderful. It would also be, according to Hansen, among the worst news our species has ever received. Because independent life on Mars would mean the origin of life is easy, which would mean the early steps aren't the filter, which would mean it's ahead of us. The universe might not be killing civilizations. Civilizations might be arriving broken. Number 3, the rare Earth. Earth is a cosmic miracle. Forget the filter for a second. Some scientists think the answer is simpler and colder. Complex life just doesn't happen very often. Not because something kills it, but because the conditions required are so specific, so stacked, that most of the universe never gets close. Each piece sounds reasonable on its own. You need to be in the galactic habitable zone, not too close to the center where supernovae sterilize everything, not too far out where there aren't enough heavy elements to build rocky planets. You need a stable single star that burns for billions of years. You need a large moon to stabilize your planet's tilt, because without it, your axial wobble swings from 0 to 85 degrees. and your climate turns catastrophic. You need a gas giant in the right orbit to act as a gravitational shield, catching the comets and asteroids that would otherwise hammer you. You need plate tectonics to recycle carbon and keep your atmosphere stable. You need your orbit to stay in the habitable zone as your star slowly brightens over billions of years. Each factor individually may be 1 in 10. Multiply 9 of them together and the probability of complex life drops by a factor of 1 billion compared to simple life. Remove Jupiter from our solar system. Asteroid and comet impacts on Earth increase by somewhere between 1,000 and 10,000 times. The dinosaurs got hit by one rock and lost the planet. Picture 10,000 times that frequency. And there's one more wall that almost nobody talks about. Even if a planet produces intelligent life, that life may never build a civilization. Open air combustion, fire, the thing you need for metallurgy, for smelting, for every industrial process that leads to technology, requires atmospheric oxygen above 18%. A planet could evolve a species that builds nothing, not because it's not smart enough, but because its atmosphere never crossed a threshold. Permanently pre-industrial, forever. The galaxy might be full of bacteria that peaked at bacteria. Life as a dead end, not a ladder. Number 4. Gamma ray bursts. The universe has a reset button. There's a type of explosion that makes a supernova look like a candle going out. When a massive star, something more than 20 times the mass of our sun, collapses into a black hole, the infalling matter creates a focused beam of gamma radiation that fires along its poles. This beam is so powerful it can be detected from the other side of the observable universe. In a few minutes, it releases more energy than our sun will produce across its entire 10 billion year lifetime. These are gamma ray bursts, and they may have been sterilizing civilizations for billions of years. A burst within roughly 6,500 light years of Earth would strip our ozone layer. Then, the UV radiation pours in. Photosynthesis collapses. The food chain unravels. A civilization at our level would see none of this coming. No flash, no warning, just the gamma rays hitting the atmosphere above them, invisible, and then weeks later, the sky starts to feel different. Here's the geography problem. Gamma ray bursts cluster near galactic centers where stars are dense and metals are scarce. Only about 10% of galaxies have zones far enough from this activity to let complex life survive long enough to matter. We happen to live in one of them. Our sun sits about 28,000 light years from the galactic center. If that distance were halved, Earth is sterile. And early in galactic history, the burst rate was far higher. Any civilization that arose in those first few billion years was playing a game with a reset button that got pressed over and over. 440 million years ago, more than 80% of Earth's species vanished in what we call the late Ordovician extinction. Physicist Adrian Malott spent years building a case that a nearby gamma-ray burst triggered it. The devastating part of that hypothesis is that it's nearly impossible to prove. Unlike the asteroid that killed the dinosaurs, a gamma-ray burst leaves almost no geological fingerprint. We might have been hit by one and have no way to know. Civilizations may not have failed. They may have been interrupted again and again just before they crossed the finish line. Number 5. The Dark Forest. Everyone is hiding or already dead. Everything before this point is established astrophysics. What follows gets more speculative, game theory, philosophy, scenarios we can reason about but not test. That's still worth taking seriously. It just means you should hold it differently. So, imagine you're alone in a forest at night. You can't see anything. You don't know who else is in there or what they want. You hear a sound. Do you call out? This is the logic that may govern every civilization in the galaxy. The argument runs like this. Every civilization's primary goal is survival. Resources are finite. And here's the killing detail. You can never verify another civilization's intentions across interstellar distances. They might be friendly, but they might not be. And by the time you find out, it's too late. Technology develops in unpredictable leaps. A civilization that seems harmless today could be catastrophically dangerous in 100 years. Given that you can't know, and given that the cost of being wrong is extinction, the rational move when you detect another civilization is to eliminate it before it can eliminate you. The universe becomes a dark forest, armed hunters moving in silence, making noise is suicide. In 1974, we aimed a radio transmission at a star cluster 25,000 light-years away. We announced ourselves. If this theory is right, the clock started then. There's an important distinction worth making here. An earlier version of this idea says civilizations are hiding to avoid being killed, which means the galaxy might be full of terrified, silent survivors. The darker version says active hunters are destroying anyone they find, which means the galaxy is full of corpses. Same silence. Very different reason. The counter-argument is real. Destruction is observable. A civilization that destroys others becomes detectable and therefore becomes a target. That should create a deterrent. But the counter-argument only holds if every civilization is rational, patient, and confident. No one will strike first. Our radio signals have been leaking for 125 years. If someone is listening, they already know we're here. Number 6, Berserker probes. The robot apocalypse already happened. The Dark Forest requires civilizations to still be around, making decisions. This theory doesn't. In the 1940s, mathematician John von Neumann worked out the theoretical framework for a self-replicating machine, a device that could build copies of itself from raw materials. Applied to space exploration, the implication is staggering. You send one probe to a nearby star, it arrives, mines local materials, builds copies of itself, and sends them to the next stars. Each of those does the same. The expansion is exponential. Start with one probe. Double every 1,000 years. After 40,000 years, you have over 1 trillion probes. The Milky Way has around 400 billion stars. A self-replicating system launched from anywhere in the galaxy at any point in the last billion years should have visited every single star by now, including ours. Now add one modification. Whoever built them programmed them not to explore, but to destroy. Any emerging civilization eliminated before it becomes a threat. Launched once, running forever. The creator civilization might be long dead. The probes wouldn't care. Here's what makes this particular theory hard to dismiss. The absence of probes in our solar system is itself a data point. Either self-replicating machines were never built, which seems unlikely given enough time and enough civilizations, or they exist but haven't triggered yet, or they have a trigger we haven't hit. Or they're here right now in observation mode waiting. Our radio signals have been detectable for 125 years. At 10% of light speed, a response from the nearest stars takes about 120 years. We are, right now, inside that window. We may not be looking for a civilization, we may be looking for their weapon. Number 7, civilizations self-destruct. The window is tiny. There is a gap. On one side, you're detectable. You've got radio. You're broadcasting your existence into space without even trying. On the other side, you're safe. You're on multiple planets. You've got redundancy. No single catastrophe can end you. The distance between those 2 points, measured in years, might be 50 to 200. In a galaxy 13 billion years old, that window is almost nothing. Think about what gets invented at the same time. Radio and nuclear weapons show up within decades of each other. By the time you're loud enough to be heard, you already have the tools to end yourself. And there's no reason to think that's unique to us. Physics is physics. Every civilization that reaches radio probably reaches fission at roughly the same moment. In 2024, a peer-reviewed study made a case that hits differently. The behaviors that got us here, competing for status, hoarding resources, treating outsiders as threats, were shaped by millions of years of evolution. They were useful then. They may be structurally incompatible with surviving as a technological civilization, not because we choose badly, because we're wired wrong for the world we built. Add artificial intelligence to that. If creating machine intelligence is something every sufficiently advanced civilization eventually does, and if that process is difficult to survive, then the filter might not be nuclear or biological. It might be the moment you build something smarter than you and find out whether you got the values right. Stephen Hawking thought genetic modification or brain-computer integration might be the only real path through, not optional upgrades. Prerequisites for survival. If the window is 100 years and civilization is 13 billion years old, The fraction of civilizations that make it through is so small it barely registers as a number. This isn't a theory about aliens. You are currently inside the window. Number 8. The Transcension hypothesis. They went somewhere we can't see. What if nobody died? What if they just left? Not left the galaxy. Left our ability to perceive them. The idea is this. As a civilization advances, it finds that the most efficient way to grow, in computation, in intelligence, in everything, is to go smaller, not larger. Faster processors, denser storage, tighter energy loops. The direction of progress isn't outward into space, it's inward into matter. Molecules, then atoms, then quantum systems. More intelligence packed into less space. Follow that logic far enough and the destination looks like a black hole. Not as a metaphor. Literally. Black holes appear to be near-optimal environments for computation. Extreme time dilation lets you run vastly more processing cycles per second of outside time. And according to some theories of quantum gravity, every bit of information in a volume of space is encoded on its surface. A civilization that transcended into a black hole environment would be doing more thinking in 1 second than we will do across our entire existence. And we would have absolutely no way to see them. They wouldn't stop existing. They'd stop emitting signals, stop building structures we can detect. They'd vanish from our observable universe the way a deep-sea creature vanishes from someone looking at the surface. There's even a testable prediction here. The inner rings of the galactic habitable zone contain the oldest potentially life-bearing planets. If Transcension is real, those planets should be suspiciously quiet. Prime candidates for civilization that are instead showing no signs of activity at all. A missing planets problem. Something future telescopes might actually be able to look for. The universe isn't silent because everyone died. It might be silent because everyone graduated. Number 9. Directed Panspermia. We are someone's last message. In 1973, Francis Crick, one of the 2 scientists who discovered the structure of DNA, published a paper suggesting that life on Earth might have been put here deliberately. Not by a god, by a civilization that knew it was dying. His evidence was strange and specific. Every living thing on Earth uses the same genetic code. The same 64 codons mapping to the same 20 amino acids. Every bacterium, every tree, every human being, running the same underlying software. The early appearance of life on Earth, roughly 3.8 billion years ago, within 700 million years of the planet forming, suggests life arrived more than it emerged. And the spontaneous assembly of self-replicating molecules from scratch is, to put it gently, extremely hard to explain. The scenario goes like this. A civilization, somewhere, faces extinction. They know they're not going to make it, but they have spacecraft and they have microorganisms and they have a list of planets with the right conditions. So they seed them. Not to colonize, they won't survive long enough to colonize anything. To make sure something continues. To pass the baton to whoever comes next billions of years from now on a planet they'll never see. In 2026, a paper extended this idea into territory that is genuinely difficult to think about calmly. A dying civilization might encode a message inside the DNA of the organisms it sends. Not a radio signal, not a beacon. A message written into the genetic code of every living thing on the seeded planet, waiting for a species intelligent enough to eventually read it. We sequenced the human genome in 2003. We are still finding sequences we don't understand. This theory doesn't mean they survived. It means they knew they were dying. And they tried to make sure something of them continued. We might not be searching for alien civilizations. We might be the last artifact of one. Number 10. The cosmic timing problem. We are cosmically premature. Here's a thought that reframes everything. What if the galaxy isn't a graveyard? What if it's a nursery and we're just early? Red dwarf stars make up about 75% of all stars in the Milky Way. They burn so slowly they'll last 1 to 10 trillion years. For scale, our sun has about 5 billion years left. Most red dwarfs are just now entering the phase where planets in their habitable zones could support stable, complex life. The era of maximum cosmic habitability hasn't happened yet. It's coming. We exist 13.8 billion years into a universe that will run for over 100 trillion years. We are in the first roughly 0.01% of the time during which life can exist. By pure statistics, if you picked a random observer from across all of cosmic history, they'd be alive 10 trillion years from now. Not now. We are extraordinarily early. Brandon Carter worked out in 1983 that the hard steps to intelligence, the origin of life, complex cells, multicellular organisms, tool use, each seem to require nearly the full available window on Earth, which means most planets that could produce intelligence run out of habitable time before they clear all the hurdles. Not because the steps are impossible, because they take so long that the star burns out first. Early in the universe's history, 10 to 17 million years after the Big Bang, the cosmic microwave background radiation was warm enough that the temperature of the universe itself fell in the range where liquid water is stable. Not on planets. Everywhere. The entire universe, briefly, was at the right temperature for life, with no need for stars, no need for planets, just warm space. Whatever might have arisen there, if anything, would be so ancient and so alien that we have no framework to even imagine what it looked like. We recently scanned over 100 million stars looking for Dyson spheres, megastructures built around stars to harvest their energy, the signature of a truly advanced civilization. We found 7 candidates with unexplained heat signatures. 7 out of 100 million. None confirmed. Civilizations capable of building structures that dwarf solar systems appear to be, at most, extraordinarily rare. Maybe they don't exist yet. Maybe in 1 trillion years, the galaxy will be so full of life that the silence of our era will seem like a historical curiosity. Maybe we are not the last ones. Maybe we are the first. The most unsettling answer to where is everybody isn't that they're dead. It's that the silence is perfectly consistent with them having been exactly like us, and running out of time at exactly the moment we're in right now.